the velocity time graph of a ball of mass 20 grams moving along a straight line on a long table is given in figure. How much force does the table exert on the ball to bring it to rest? So we are looking at velocity time graph. The velocity is along the y-axis and time is along the x-axis. So the units are, here we have the velocity to be in centimeter per second and the time is in second. Always start the graph by reading the heading, looking at what is along the x and y axis and also the respective units, and then you should read the values from the graph. So when t is equal to 0, the object has a velocity of 20 centimeter per second. The object came to rest at time t is equal to 10 seconds. So these are all the data that we need for this question. So let's show this on a diagram, free body diagram. That is basically your given. Okay, we have the object moving and coming to rest. So initial condition means what? T is equal to 0 seconds. The velocity of the object was how much? 20 centimeter per second. And this came to rest in a matter of 10 seconds. That is, the velocity, final velocity is 0 meter per second. The mass of the object is how much? 20 grams, not kg, grams. This is what we have to make a note of. Okay, now that is your diagram. Before we calculate anything, we need to convert the unit. U is 20 centimeter per second, right? So we have it in centimeter, we have to convert it to meter. 1 centimeter is 1 by 100 meters. This is 20 by 100 meter per second. So this is 0.02 by 10 meter per second. Right, that's your initial velocity. The mass is in grams, we have to convert it to kg. So 1 gram is nothing but 1 by 1000 kg. So we have to divide over here with 1000 or multiply with 1 by 1000. So many kg. So basically this is nothing but 20 by 100 kg, right? This is your initial velocity and the mass in the respective units. Now we can make use of this data. Always convert the data to the required unit and then start working. We have the force being equal to mass and acceleration, product of mass and acceleration. We have the mass, but we don't have the acceleration. So we have to figure out the acceleration. How do you do that? With the help of v is equal to u plus at, right? So we know the final velocity, that is 0. What is initial velocity? 20 by, or I think 2 by 100, 2 by 10, sorry. 2 by 10 plus acceleration is, well, we have to figure it out. Time is 10 seconds. So further calculation is, we'll subtract minus 2 by 10 both the sides. So this and this get cancelled. So we have minus 2 by 10, which is equal to 10a. Then we divide with 10 both the sides. So this is basically minus 2 by 100 meter per second is your acceleration. Second square is your acceleration. Okay, we know the acceleration now. All we have to do is substitute in force is equal to mass. Mass is 2 by 100 into minus 2 by 100. 2 by 100, right? So we have plus of minus is minus. 2 into 2 is 4 by 1, 2, 3, 4. 1, 2, 3, 4. And we have this to be equal to 0.1234 Newton and negative. Why negative? Because the force of friction is always opposite to that of motion. Here we are considering right as positive. The negative indicates that the force is to the left, and we can see even the acceleration was negative. So the direction of acceleration was also to the left. And this is your answer. So let's write a statement. Force exerted by the table is 0.0004 Newton.